Yeah, Nitish, you can start the session now.
Okay, sure. Am I audible, everyone? Hello?
Yes, you are audible.
So let us start then. Okay, so today we're going to start with a new topic altogether. Give me a link. I'm just opening the file.
Excuse me, sir.
Yes.
So for both Saturday and Sunday is there holiday, or only for Sunday it is holiday?
Saturday, Sunday is holiday.
Okay. Thank you.
Visible class.
Yes, sir.
Perfect. Okay, so today we're going to start with a new topic. Okay, so that is your data analysis in Python. So we're going to cover some topics related to your data analysis only. So data analysis involves a broad set of activities to clean, process, and transform our data collection to learn from it. Okay, so Python, we are going to use Python. Python is used as a programming language to perform data analysis because many tools such as your Jupyter notebook that we're already using. Okay, this one. Okay, your pandas. Okay, pandas is one of the most famous libraries that is used in data science and data analysis both, and machine learning too. Okay, are written in Python and can be quickly applied rather than coding your own data analysis libraries from scratch. Okay, so now we are going to start with data analysis class. In data analysis, there is a module. Okay, there is a module called as NumPy. Okay, so since all of us are using Anaconda right now, okay, so in our system, your NumPy is also installed along with Anaconda. But otherwise, your NumPy is an external module. NumPy is an external module. It is not present in Python. Okay, it has to be installed separately. Okay, but since we're using Anaconda, so what happens? See, Anaconda is basically it is a complete software. Okay, for data science and machine learning and data analysis purpose only. So all the packages, all the libraries, all the modules that we majorly require in data science, okay, come pre-installed along with pandas. Okay, so that is why NumPy is already there in the system. Okay, so we are going to simply import it. Import as NP. It might take some time here. Start. Okay. Now NumPy, which stands for numerical Python, is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Okay. Using NumPy, mathematical and logical operations on arrays can be performed. Okay. Mathematical and logical operations, Fourier transforms and routines. Okay. Operations related to linear algebra. Okay. Your trigonometry. Okay. We can work on trigonometry also using NumPy. Your random number generation. Okay. We can work on linear algebra if you want to. Okay, then we can work on metrics. Okay, metrics. Okay, that is the most important thing in NumPy. We will see it. Okay, so now inside NumPy class, we are going to study a particular data type. Okay, which is called as array. Okay, in Python, in core Python class, in core Python, we already know list. Okay, we already know tuple. Okay, we already know set. Okay, and we know that these are sequence data type which can store multiple elements. Your string is also there. Okay, your dictionary is also there. Okay, so this can store multiple elements. Now, these are present in core Python, right? They're already there in core Python. Okay. Now, in NumPy, we're going to study another data type called as arrays. okay, which are defined in NumPy only, which is not present in core Python. Okay, if you want to work on arrays, we need to use NumPy. Now, in case of list class, we already know that list is heterogeneous. That means the elements of the list can be of different data types. First thing. Second thing, repetition is allowed in list. Okay. Now, in case of arrays class, see, list is heterogeneous, but arrays are homogeneous. Arrays are homogeneous. Here you can see it describes the most important object defined in NumPy is an n-dimensional array type called as ND array. Okay, ND array means n-dimensional array. N-dimensional array. Okay, it describes the collection of items of the same data type. Okay, items in the collection can be accessed using a zero-based index. It means indexing is possible and indexing is starting from zero. Okay, so that is there. Now, class, there is 1D array. Okay, 1D array looks like this. Here you can see one dimension. Two dimension. Here you can see there is two axes. Axis 0, axis 1. Okay, or we can also uh, like informally we can also say this is 2 rows and 3 columns. Okay, here you can see 3D array. So there are, you can see 4 channels, or we can say 4 layers also. 4 layers. Okay, then 3 rows. Okay, and 2 columns. This is how it works. Okay, 2 rows, 2 columns, 3 rows, and 4 channels or 4 layers. You can say 4 channels also. You can say 4 layers also. Okay. So now, class, we are going to create an array first. How? Now see, arrays are present in NumPy. That is why in Python we cannot directly create the arrays. Okay, rather we can typecast a list to an array. List or tuple or set, we can typecast them to an array. Okay, suppose I am writing here 1, 2, 3, 4. Okay, this list is there. Now I need to typecast it. So I can write here A is equal to np dot array. Okay, in C class we got an array. Now in case like in list we use square brackets, in tuple we use parentheses, in set we use braces. Okay, in array we use this. Okay. In some, it depends on the software also. In some softwares arrays are also represented by this also. Okay. But you can always check. You can always check the type here. If you write the type of A, it will give us numpy.nd array. Okay, here you can see it is given numpy.nd array because it is present inside numpy. ND array means n-dimensional array. Now we can, if you want to see the number of dimensions, if you want to see the number of dimensions here, we will write here n dim. A dot n dim. Number of dimensions one only. Here you can see single dimension. Okay, A dot shape. A dot shape. Here you can see 4. A dot size. A dot size will give us the number of elements. There is 4 elements are there. Okay, your and dim. A dot shape. A dot size. Okay, then one more is there. A dot D type. Here you can see when we write D type. So here when we write type of A, it is giving us the data type of the whole array. When we write D type, it will give us the data type of the elements of the array. So you can see all the elements here are in integer format. So if I run this code, I'll get int 32. That means 32-bit integer. 32 means amount of space that they are using. So int 32-bit integer. Okay. Now class, let us create a 2D array. Okay, I will write here B is equal to np.array. First row. Okay, second row. 5, 6, 7, 8. So here you can see class, this B is a 2D array. If I write here B dot endian, and it was giving it as 1 here. If we write here B dot shape, it will give us 2, 4. 2 rows, 4 columns. Okay, if I write here B dot size gives us the total number of elements in the array. Size can also be calculated from shape. Okay, 2 into 4 is equal to 8. Okay, then next is your okay. So in 32 only. Now one thing class, just to like, if you want to recognize what kind of how many dimensions are there in the array, you can also look at the brackets too. Okay, here you can see single bracket. Single bracket means one dimension array. Okay. Okay, in this case, here you can see single bracket. Here you can see double bracket. In the starting also, in the end also. Okay, so that is your 2-dimensional array. This is a single 1-dimensional array. Okay, so this is how your NumPy works. Okay, now class, one more thing. When there are more than equal to 2 or more than 2 dimensions, your array is also called as matrix. In single dimension also, it is called as matrix in column. Okay, because a single dimension object can also be 1 dimension. Array can also be written as matrix only. Like for example, in this case, that this matrix can also be written as 1 into 4. Okay, even though there is 1 dimension only. Okay, let's continue now, class. Okay. Next is there are multiple ways to create arrays. We saw this. Okay, I'm going to do one thing here. There is an addition when we're creating arrays. There is an additional argument that you can pass. You can pass here d type is equal to float. Okay, so here you can see now in the resultant array, all the elements of the array are of float on. Okay, here they are in integer format. Here they are typecasted. See, the data that you passed is in integer. Okay, but it is storing in float format. Let's continue. Next is your class. C dot. Okay, I can write here C is equal to NP. You don't need to save it again and again. I'm just showing you how to create arrays right now. Next is your zeros. NP dot zeros class. Okay, so it will like suppose if I pass here 3, 3, 3. Okay, so it will create a 3D array. It will create a 3D array. Let me show you. 3, 2, 4. Let's say it will create a 3-dimensional array of this particular shape. Okay, having all the elements are 0. Okay, and here in this case by default the elements are going to be of float type. Okay, so you can see there are 3 layers. Okay, 2 rows and 4 columns. Okay, here you can see brackets also. 3 brackets means 3-dimensional. Let's continue class. Okay, in this case there is another option. Suppose see by default the data is present in float format. Here in this case 0, 0, all of them being 0. Now if you want to save the data in integer format, you can pass this argument dtype is equal to int. Type is equal to int. You can see automatically that the data will be stored in integer format. So zeros is there. Similarly, one more is there called as ones. Okay. Here also I will pass a size. Let's say I'm passing here 4, okay, so here you can see it is creating all the elements. It is creating an array of 4, 3 where all the elements are 1. Where all the elements are 1 only. Okay, same thing dtype you can pass here also. Now class see there are zeros. There is a method. There is a function for zeros and ones only. Okay, we don't have for 2s, 3s, 4s and so on. We don't have functions for them. If we want to implement them, there is a way to do that. But here normally zeros and ones are there because they are zeros and ones are also used as binary values. Okay, true means 1. Okay, true can also be written as 1 and false can also be written as 0. Okay, so here for other numbers we can write here np dot full. Okay, then we mention the size here. Let's say I will mention 2,2 and then the number that we need. Let's say I will mention 8. So you can see 2,2 an array of 2,2 and all the elements is 8. Okay, here also you can pass data if you want to. Okay, now let's continue class. Next is your np dot a range. You can write here c is equal to np dot a range. Okay. All of us know the range function in core Python, right? If I write here range 2, 10, okay, it will create a range for us. Okay, like it will create a sequence of elements for us. Okay, iterable sequence. We have to typecast it if you want to see it. You can see it is creating a sequence, iterable sequence for us from 2 to 9. Okay, that means whatever number you will mention here, it will go till -1 of that. Okay, m comma n, it will go till n minus. From m, it will go till n minus 1. Okay, so list. Okay, so this is presenting core Python. Okay, similarly, we have one more function. Okay, in NumPy also for creating array in such a manner and period a range. A range means your array range. Okay, and same thing we will pass at 2, 10. So in this case, we'll get an array. Same data, but in array form. Okay, so here your step size will also work. If you want to take step size of 2, maybe. Okay, that will also, you can see 2, 4, 6, 8. Step size of 2. A range is there, class. Now in case of A range, what happens? In case of A range, what happens? It returns evenly spaced values within a given interval. Okay, step size is given. Okay, so what range do we want? Okay, what range do we want that we mention, and how much space do we need between the values that also we specify? Okay, here we can see we have mentioned the step size. So step size is basically nothing but your space only between the values. Space between 2 and 4 is 2. Space between 4 and 6 is 2. Space between 6 and 8 is again 2. So here we mention the space. How much space do we want between the elements? Okay, let's continue. Okay, similarly, there is another function called as Lin Space. Okay, Lin Space called as linear space. Okay, here in Lin Space we mention the number of elements that we want, and the space will be calculated automatically by the system. It's by the Python itself. So np dot linspace mention here. Let's say 2, n, 3. Okay, this means that in the range of 2 to 10, I need 3 numbers. So here you can say it is basically equally spacing the whole range into 3 equal parts. See, 6 minus 2 is 4, 10 minus 6 is also 4. Okay, suppose if I enter here 4. Okay, so 4 equal parts. Okay, suppose if I enter here 5. So you can see 5 equal parts and so on. This is how this thing works. Give me a minute. Let's continue class. Next is your reshaping arrays. Okay, so how it works? Let's suppose we have this array with us. Okay, B array with us. Okay, B array is there. Now, the size of this array is, the shape of this array is 2 cross 4. Okay, 2 cross 4 is 2 rows and 4 columns. Now, what is the meaning of reshaping class? Okay, it is possible to reshape an array, okay, from one shape to another, okay, provided the size of the array before reshaping and after reshaping remains same. Okay, we can reshape an array only and only when the size of the array remains same. Okay, that means we have to write this. Okay, we have to make the shape of the resulting array, okay, as such that the multiplication of that shape is basically same as this 4 into 2 8, right? So I can reshape it to 4 into 2. Okay, I can reshape it to your 8 into 1. I can reshape into 1 into 8. Okay, I can reshape to, I guess, 2 into 2 into 2. Okay, we can change the dimensions also if you want. 2 into 2 into 2. Okay, I can reshape it into your, I can rearrange this. Okay, so that is how this thing works. Okay, suppose if I write here B array is here, I will write B dot reshape and the of the resultant array. Okay, so here in this case you can see the array was this. Now we have reshaped it to this 2 comma 4 to 4 comma 2. Okay, suppose if I write here 4 comma 2 comma 2 again, so it will throw an error that cannot reshape array of size 8 into shape this, because 4 into 2 into 2 is 16. Okay, and size is 8. Think about it. Size means the number of elements. If the size is changing after reshaping, that means new elements are getting added into the array, or maybe some elements are getting deleted. So obviously that is not possible. Okay, that is why the size should remain same. I can write here 2 comma 2 comma 2. Okay, so you can see 2 comma 2 comma 2. So this is how your reshaping array works. Let's continue class. Next is your flattening the array. Flattening the array means if we want to take the whole array and collapse it into one dimension. Okay, let's say your B is there. Okay, B array is this. Okay, if I want to save this now, I have to save it separately after reshaping like this. B array is this. Suppose if I want to convert it into single dimensional object, so I can write here B dot flatten. That's it. So whole array will get converted to single dimension. Same thing happens here also. Suppose if I do with D, if I write a D dot flatten, so here you can see the whole array, whole 3-dimensional array, 2 comma 2 comma 2 got flattened, got changed into, got collapsed into single dimension. Let's continue class. Next is your array indexing. What is the meaning of class array indexing? Just like suppose we have list with us. So if I write here L of 0, okay, it will give me 1. Similarly, here also we have array indexing available. Okay, how it works? Suppose we have an array A. Let's check B array for now. Okay, so in this case, if I write here B0, let's check A for now. Okay, let me show you A first. If I write here A0, it will give me 1. This is the 0th element. Similarly, if we have B array with us, class, so if I write here B0, so it will give me if I write here B0, it will give me the first row completely, because this is 0. This is 0th row and first row. 0th column, first column, second column, third column. Okay, so if I write here B0, or 2. So B0 is this. Okay, and B of 0 of 2 will become is 3. Okay, so you'll get 3 in the output. Okay, so this is class. This is how your array indexing works. Okay, this is just simple basic indexing. Now there are two more types of indexing available in arrays. Okay, called as your indexing. Okay, indexing. Now how it works? Let's say your B array is there. Now let's say from the B array, I want these two elements separately. Okay, so now what are the coordinates of these elements? First coordinate of like the coordinate of 2 is 0, 1, and coordinate of 3 is 0, 2. So now in this case class, if I write here B, I will pass two lists. Okay, first list will be for row coordinates, and second list for the column coordinates. So row coordinates are 0 and 0. Okay, so I will write here 0, 0, and column coordinates will mention as 1, 2. In this case, you will see that we got 2 and 3. Here class, we first need to pass row coordinates and then column coordinates. Let's continue. Next is your Boolean array indexing. Boolean array indexing. Now, what is the meaning of Boolean array indexing? Here we pass a Boolean constraint. Here we pass a condition on the basis of which you want to index. Suppose I say that I want to take out all the elements from the array, okay, which are greater than 5. Let's say greater than 5. So here I can write B, then bracket I will write a B greater than 5. See, in the resulting array, I am getting all the elements which are greater than 5. Suppose if I write it less than 2, maybe, or less than 5, maybe, here you can see we're getting 1, 2, 3, 4. Okay, suppose I say, see, we can pass any condition here, any condition at all. Okay, suppose I say that I want to take out all the elements, okay, which are even number. I can write here B modulus 2 equal to 0. Okay, so you can see whichever elements are satisfying this particular condition, we're getting their output 2, 4, 6, 8. Whichever elements are satisfying this particular condition. Okay, so let's continue class now. Let's continue. Okay, so this is your integer array indexing and Boolean array indexing, and this is your general indexing that we already know. Next is your class slicing. What happens in case of slicing? Suppose your B array is there, okay, and you want to, let's say, slice out, okay, these two elements 6 and 7. Okay, now here, see, first thing that we need is your first row. Okay, and then we need, see, out of 0 and 1, we need first row. Okay, and out of this 0, 1, 2, 3 columns, we read column 1 and column 2 only. Okay, so I can mention here B. We need to do slicing. First, we will do row slicing. So for row slicing, I will mention here 1 column. Okay, because 1 column means 1 till the very end, then comma, and then column index. Column I need 1 and 2. So I can write here 1 column 3. 1 column 3 means 1 and 2. Okay, so here you can see we are getting 6 and 7 in the output. 6 and 7 in the output. Your step size will also work here. Your step size will also work here if you need anywhere. Okay, class, this is it. Indexing and slicing. Let's continue. Okay. Next are your operations on arrays. Simple operations you will see. Arithmetic operations. Okay. So class, what all arithmetic operations do we have? Okay. We have studied 7 arithmetic operations, right? We have studied 7 arithmetic operations so far. In core Python, okay, there is your plus operation. There is your subtraction, addition, subtraction, multiplication, division, power, modulus, and floor division. Okay, so all of this can be used here also. How? Suppose your A array is there. Right here, A plus 1. So you can see 1 will get added to each and every element of the array. Obviously, changes won't be permanent. You have to save it in some other variable. Okay, so either you can write here, let's say E is equal to A plus 1. So in E array, okay, you can see A is still the same. A is still the same. Okay, but in E, 1 is added to each and every element of the A array. Okay, similarly, your all the operations will work. Suppose I write here A star star. So you can see power. Okay, power operator is applied on each and every element of the array. Okay, now class here you can use assignment operator. Also. So when do we use assignment operators? When we use them when we want to do some arithmetic operation and save the data in the same variable itself. Suppose if I write here A is equal to A plus 1. Right? Now this same thing can be written as, see, A is this now. Now this same thing can be written as A plus equal to 1. Now 1 will get added in the A. So all the arithmetic operators and all the assignment operators we can use. Okay, so these are operations class. Let's continue now. One more thing, let's say B array is there. See, same thing can happen in 2-dimensional array also, no problem in that. Now B array is there. Suppose if you want to calculate find out the transpose of this array. So we have to write B dot T. So we got the transpose. You can also write it as B equal to B dot T. So the changes will get saved in the same variable. Let's continue now. Next is some unary operators. Okay. What are they? Suppose class if I write here max of B dot max. Here it will give me the maximum element in the whole array. B dot min will give me the minimum element in the whole array. B dot mean will give me the mean value, okay, average value. B dot median is no, it won't work. Median is not there. B dot your mean also not there. Your cumulative sum is there. Plus B dot cumulative sum is there. What is the meaning of cumulative sum? What is the meaning of cumulative sum? Cumulative sum means sum of the current input and the previous output. Sum of the current input and the previous output. Suppose the input is 1. So answer will be 1. Input is 5 now. Now answer will become 5 plus 1. That is 6. You can see 6. Then next is 2 input. So 2 plus 6 is 8. Then next is 6. So 6 plus 8 is 12. 8 plus 14. So you can see 14, 8. The next is 3. So 14 plus 3 is 17 and so on. Okay, so this is how this particular thing works. Cumulative sum. Sum of the current input and the previous output. Same thing here. We have cumulative product also. It means product of the current input and the previous output. Product of the current input and the previous output. Cumulative product. Okay. Now class, next is your. Let's say we have 2 arrays with us. Let's say your B array is there. Okay, let me create one more array now. plus this is your F array. Okay. Now what I'm going to do, see, I'm going to add them. Okay, we have two arrays B and F. Okay, and we are going to add them. So if I write here B plus F, okay, so here you can see it is basically getting added. The corresponding elements of B, 11 plus 1, 12, 51 plus 5, 56, 22 plus 2, 24, and so on. So here also you can class apply all the arithmetic operations that you know. Okay. If I write here, let's say F divided by B. Okay, so see 12 divided by 1, sorry, 11 divided by 1, 11. Okay, 51 divided by 5, 10.2. Okay, and similarly all the data that we are getting here. Okay, so that is that. And next, okay, now in this case, class, one thing, let me show you. Suppose if I write here B dot F, B multiplied by F. So here you can see it is, we are getting basically a multiplication of the elements. Okay, corresponding elements. So this is simply called array multiplication. So far we are using the term matrices, right? And we all know that matrix multiplication is different from normal multiplication. So matrix multiplication can be implemented by, okay, a method called as dot method. Okay, and there is a condition in matrix multiplication, if you remember. Okay, suppose we have two matrices and the shape of this is A into B. Okay, and we are multiplying it with another matrix and the shape of this is C into D. So B equal to C. Then only matrix multiplication is possible. This should be true. Okay, and one more thing, A into, and the resultant matrix shape will be A into D. Okay, so let's say we have B with us, and let's say if I write here F dot T, F dot T is there. Okay, so if we multiply them plus B dot F dot T like this, you see we got an output. B is what? 4, 2. This is 2, 4. So 2 and 2 are same. Okay, and the resultant matrix will be of size 4, 4. You can see 4, 4. That is your matrix multiplication. Now there are simple trigonometry operations are also there. Simple trigonometry operations are also there in your NumPy. Okay, what are they? Suppose if I write here np dot sine, if I write here, before it, let me show np dot pi. Okay, so np dot pi is present here, pi value is present here in your NumPy. 3.148 is present as a variable inside the NumPy library. So if I write here class np dot sine of sine 0 is 0, we know. Okay, simply if I write np dot sine of sine of pi by 2. Okay, sine pi by 2 basically. Sine pi by 2. Sine pi by 2 is 1, we know. Similarly, cos is there, tan is there. Now let's say class, suppose A array is there. A array is there. Okay. Okay, so if I write here dot sine of A also. So here also it will give me resulting array. Here we are getting a single element only because we have passed single element. But if you pass a whole array as an argument here, so the output will also become a whole array. Sine 3 is this much, sine 4 is this much, sine 5, sine 6, and so on. Okay, similarly, suppose class this kind of questions now we create an angle array first. How? We'll write np dot a range from 0 to, let's say, 2 pi. 2 pi is basically your np dot pi into 2. Okay. We will take a step size of maybe See, by default, it will take a set of one only that we know. Okay, one only. Okay, so we take more data actually. We take more data. Let's say we are taking steps 0. Okay, so you can see we are getting a lot of data points. Now here we write NP angle. Okay, and then we will create y axis. Y axis is equal to NP dot sine of angle. You can see we are getting a 1D array only. This is one dimensional array. Okay, but basically we are getting sine value of each and every element here. Okay, so here class, in this case, angle is called as an independent variable. Okay, this is your independent variable because it is not dependent on anything. Independent variable. And here y is called as dependent variable because y is dependent on the value of angle. Y is dependent on the value of angle. So it is dependent. Okay, in that we are studying trigonometry and all. Okay, so that is that. Now other functions are also there. Okay, such as suppose if you want to square root of some number, square root of 9, 3.0, np dot power function is there. Okay, so if I write here 3, 2, so 3 ka square, this means 3 raised to our square. Then log is there, exponential is there, np dot exponential. Okay, let's say 2. So you're getting basically np dot e is there. Okay, so when you say exponential function, so basically this is basically a raised to our 2. Okay, so e value is 2.7. Similarly, log is there. Okay, np dot log with base 10 2. Log 2 with base 10 is 0.3010. Okay, natural log is also there. Log of 10. Okay, that is also there. Plus. Okay, then np dot seal is there. Seal, I guess. Let us check. Should be there. Huh. So this is your ceiling. Ceiling I started explained in the starting when I was talking about floor division, right? Floor division and ceiling. Okay, ceiling basically 3.4. It will give a bigger number. Okay, then 3 point bigger integer. Okay, which is nearest to it. Okay, simply np dot floor is also there, which is opposite of this. It will give a smaller number nearest to it. So 3.4 give us 3. Ceiling floor. np dot. What you can do, class? Suppose if you want to see all the functions that are present here, you can write here np dot and then press tab. It might take a time. So you can see absolute value, multiple all, okay, any, append, angle, a range that we have already covered. A lot of functions are present.
Sir,
Yes.
sir, can you show how we can an user can input the values to the array?
See, that is, you cannot directly give data to the array, na? You have to first create a list and then you can typecast that to an array, right?
Okay.
Getting this. Array is not present in core Python, so we cannot create array directly.
So we have to make the user to input the values to a list, then we have to convert into array.
List or set, any one of them.
Okay, sir.
So, one more topic that is left here is a random array generation. Suppose if you want to randomly generate some array class, randomly. Suppose if I write here np.random dot rand int. Okay, so here if I write mention, let's say 2, 10. So here you can see randomly. See, if I run this cell again and again, randomly it will give us some number within this range only, randomly. Okay, you can mention shape also. Okay, let's say you mention here 3, 4. And let's take a bigger range, maybe 20. Okay, so you can see from 2 to 20, it is giving us giving us an array of 3 by 4. And all the elements of the array are in the range of 2 to 20 only. And if you run this again and again, randomly it will change. But random dot rand n is also there. Okay, rand n basically gives us on the basis of normal distribution. Normal distribution. So I will mention here, let's say 2, 2 for now. So we have to mention the range also. 2, 10, let's say. So you can see it is creating giving us an array of 2 by 2 of normal distribution. See the output is basically taken from a normal distribution. Normal distribution, all of us have studied, right? In your probability. Okay, normal distribution is there. Similarly, there is uniform distribution also. So NP dot uniform is there. Uniform. Here also, if I mention 2, let's take 4, 3 maybe. Okay, so here you can see it is giving us a single output. Okay, so in the uniform, in this case, you have to mention the range. Suppose I mention the range as, let's say 4 to 9 and shape as 3. So you can see all the elements here are basically calculated according to the uniform distribution of the range of the given range 4 to 9. All the elements are in the range only. Okay, so rand n is there, okay, there is one more thing. Suppose there is a list with you. Okay, 1, 2, let's suppose some kind of collection is there. Let's say string is there with you. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and some data is there. Let's say some vowels are there. A, E, I, O, U. And digits are there. Now suppose if you write here plus np.random.choice. In this case, you can see array was in one dimension or an integer. Achha. So I guess we can create an array out of it. Okay. And here we will mention essay. Minute class. Achha. Okay. Wait a second. Okay, so here you can see string data, right? Now here I told you that list that array should be homogeneous in nature. Array should be homogeneous in nature. That means all the elements of the array should be of the same data type. Okay, in this case, all the elements are not of the same data type. Some are integer, some are your string values. That is why it is converting all of them to a single data type called as Unicode. It is encoding all of them into a single data type. Now, if we write this code class. So randomly, every time if I run this code, every time you can see it is randomly giving me some data from the array. Digit or some vowel. And it is your choice. Okay, remember your choice. You're always work on one dimensional array only. Here the argument should be one dimensional array only, nothing else. Only that will work. Okay, so yep, that is all about your class NumPy. That is all about NumPy. Okay, I have to start a new topic. So it is already, I guess, yeah, time is already done. So we can start the new topic in the next section. Okay, so is there any doubt, anyone class?
Sir, can you explain slicing again?
Slicing, sure.
$57th code.
I'm writing again. Let's say you have B array with you. And from the B array, you want to slice out this two. Okay, so here you can see this is 0, 1, 2, 3. This is 0 and 1. Now in case of C, this is two-dimensional array, so we have to do slicing. We have to slice the row also, we have to slice the column also. In case of rows, we can see that we need 0 and 1, and in the column we just need the 0th column only, right? So in this case we can mention B first, see, comma. So before comma we have to do row slicing. That means we need 0 and 1. So for 0 and 1 we can write here 0 colon 2, right? When we write m colon n, so it starts from n and goes on till n minus 1. So because I need 0 and 1, that is why I'm writing 0 colon 2. Okay. And column slicing, which column do I need? 0th column only. So I can mention here 0 colon 1. Okay. You can see we are getting 1 and 2 in the answer. Is it clear now? Is it clear now, class? Everyone?
Yes, sir.
Yes, see, even if you don't mention 0, whenever the slicing is starting from 0, you don't need to mention 0. Same output you will get. Colon obviously there, colon 2, colon 1. Okay. So yeah, that is all for today class then. Okay, everyone.